This is a video from section 3.4. It's on the chain rule. And in this video, we're going to go over Leibniz notation, which says the following. If y equals f of u and u equals g of x are both differentiable functions, then dy dx is equal to dy du times du dx. And the directions here say to find the derivative of the given function. And we're going to start with problem 7. Suppose f of x is equal to 2x cubed minus 5x squared plus 4 raised to the 5th power. Now, you want to look at u, right? And think about the inside function. The inside function in problem 7 is what's going to be in parentheses. And so in this case, it's going to be 2x cubed minus 5x squared plus 4. And I want to define y in terms of u. So y is going to be u to the 5th. Now, du dx is 2 times, and here I'm just applying the power rule. Now, the derivative of x cubed is 3x squared. And so we get 2 times 3x squared minus 5 times the derivative of x squared is 2x. And the derivative of 4 is 0. So this is 6x squared minus 10x. And if you don't mind, I'm going to factor out 2x and write this as 2x times 3x minus 5. And dy du is 5u to the 4th. So I'm just applying the power rule here. And what's nice about this is to get f prime of x, you get dy du times du dx. So there's a lot of reliance on rules that we've already established before, okay? Now, dy du is 5u to the 4th. And then du dx is 2x times 3x minus 5. Now, 5 times 2x is 10x. And remember, we have to put back what u is. So remember, u is 5, let's look back actually. U is 2x cubed minus 5x squared plus 4. And then we're going to raise that to the 4th power and then multiply by 3x minus 5. And so we're going to call this f prime of x. And that's the answer to problem 7. If we take a look at problem number 9. So here f of x is equal to the square root of 5x plus 1, which is equal to 5x plus 1 to the half. Now, the inside function here is 5x plus 1, so we're going to let that be u, okay? And then y is expressed in terms of u. So y is u to the half. Du dx is equal to 5 times 1 plus 0, which is equal to 5. And then dy du is 1/2 u to the negative a half. That's just power rule. But this is 1 over 2u to the 1/2. But I can write dy du as 1 over 2 square root of u. Okay? So if I want f prime of x, this is equal to dy du times du dx. But this is 1 over 2 square root of u times du dx, which is 5. So I'm going to put a 5 here. So remember that u is 5x plus 1. So I'm going to write f prime of x as 5 divided by 2 square root of 5x plus 1. That's number 9. Let's take a look at number 11. Suppose g of t equals 1 over 2t plus 1 to the second. But I'm going to write this as 2t plus 1 raised to the negative 2 power. Now, again, my inside function is what appears in parentheses. And so in this case, u is going to be 2t plus 1. And then that says y is u to the negative 2. So du dt this time, so t is taking the place of x in problem number 11. This is equal to 2 times 1 plus 0, which is equal to 2. dy du is negative 2u to the negative 3. But I want to get rid of my negative exponents. So if you don't mind, I'm going to write this as negative 2 divided by u to the third. Therefore, g prime of t, so when I take its derivative, I get dy du times du dt. Okay? And so this is negative 2 over u to the third, right? That's what dy du is, times 2. But remember that u equals, in this problem, is 2t plus 1. So therefore, g prime of t is negative 4 divided by 2t plus 1 to the third power. That's problem number 11. Let's take a look at 13. Suppose f of theta is equal to cosine of theta squared. So my inside function here will be the argument of the cosine, which in this case is theta squared. So I'm going to let that be u. So y is cosine of u. Okay? Now, f prime of theta, so to take the derivative here, I'm going to go dy du times du d theta. Now, dy du, in this case, is negative sine u. So if you don't mind, I didn't write down explicitly what dy du was just yet. So I'm going to do it here. Dy du is negative sine u. Du d theta is equal to 2 theta. But remember that u is equal to theta squared. So therefore, f prime of theta is negative 2 theta sine of theta squared. and that's problem 13. Let's take a look at 15. Suppose g of x is equal to e to the x squared minus x. So I'm going to let u be x squared minus x, and then that says y equals e to the u. Now, again, we can go back. If people are more comfortable, it's fine. We can write du dx here. It's totally fine. Du dx is 2x minus 1 here, and then dy du is equal to e to the u, like so. And so g prime of x is dy du times du dx, but dy du is e to the u, and du dx is 2x minus 1. And so, therefore, g prime of x, I'm going to replace u with x squared minus x. So this is 2x minus 1 e to the x squared minus x. And that would be the solution to problem number 15. I want to take a look at problem 17. Suppose y equals x squared e to the negative 3x. Now, this is a classic product rule problem. And so if I want y prime, I'm going to get the first function, which is x squared. I'm going to multiply by the derivative of the second function with respect to x. So in other words, I'm going to multiply by the derivative of e to the negative 3x with respect to x. I'm going to add e to the negative 3x times the derivative of x squared with respect to x. So we're multiplying by the derivative of the first function with respect to x. So that's product rule. Now, let's let g of x equal e to the negative 3x, because we're going to need its derivative. So let u be equal to let u equal negative 3x. Du dx is going to be equal to negative 3. And we'll say y1 to distinguish it from the y we're already using. So let y1 equal e to the u. And so the derivative of y1 with respect to u is equal to e to the u. Okay? And so g prime of x is equal to dy1 du times du dx, which is going to equal negative 3e to the u. But remember that u is negative 3x. So this is negative 3e to the negative 3x. Okay. Now, we need that over here. So y prime is going to be x squared times the derivative of the second function, which is negative 3e to the negative 3x, plus e to the negative 3x, times the derivative of the first function with respect to x, which in this case is 2x. And I can factor out an x e to the negative 3x from both terms. And when I do that, I get negative 3x plus 2. And that's equal to y prime. And that's the answer to problem number 17. I want to take a look at problem number 25. Suppose y equals e to the tangent theta. Okay, so I'm going to let u be equal to tangent theta. And if you don't mind, I'm going to call this y1. y1 is going to be defined in terms of u. So in this case, will be e to the u. du d theta is equal to secant squared theta. And the derivative of y sub 1 with respect to u is equal to e to the u. So dy d theta is the derivative of y1 with respect to u times du d theta. Okay. Now, probably what we could do to avoid confusion, call this y prime. Okay, because really we're taking the derivative of y with respect to theta. Okay. So this is e to the u times secant squared theta. But u is tangent theta. So y prime is e to the tangent theta times secant squared theta. And that's the answer to problem number 25. And I want to take a look at problem number 29 for the last question of this video. Suppose r of t is equal to 10 raised to the power of 2 square root of t. Now, what I'm going to do is the following. I'm going to write r of t as e raised to the natural log of 10 raised to the 2 square root of t, like so. Now, this is equal to e raised to the 2 square root of t times natural log of 10, which is equal to e to the 2 natural log of 10 times the square root of t. Okay. I know how to take the derivative of an exponential. And so I rewrote 10 raised to the 2 square root of t in terms of an exponential function with base e specifically. Now, I'm going to let u be equal to 2 natural log of 10 times the square root of t. And so y is equal to e to the u. And so du dt is 2 natural log of 10 times 1/2 t to the negative 1/2. Okay? Which is equal to, now notice how the 2's cancel. And so this is natural log of 10 divided by square root of t, like so. And dy du is equal to e to the u. And we're in business because now we can get r prime of t. This is dy du times du dt, which is e to the u times natural log of 10 divided by square root of t. But u is equal to 2 natural log of 10 times square root of t. So r prime of t is equal to e to the 2 natural log of 10 times square root of t times, and then I'm going to multiply by natural log of 10 divided by the square root of t. But if we recall, let's go back. Notice how e to the 2 natural log of 10 square root of t is equal to 10 raised to the 2 root t. So we can write this as 10 to the 2 root t times natural log of 10 divided by square root of t. And that's the solution to problem number 29. And that's going to conclude this video for section 3.4. We worked on problems 7, 9, 11, 13, 15, 17, 25, and 29. Thank you.